Hello my dears, very good morning to all. So in the last class we studied about the concept of why a single phase induction motor is not self-starting, and the concept of double revolving field theory. It's actually a very difficult portion, but you just remember that equivalent circuit and all, and main thing you just remember the forward slip is S and the backward slip is 2 minus S. That is the only thing you have to remember there. Remain all for just your information, first just your knowledge only. Okay, in examination and all it won't be asked. Only the thing to be asked in examination is that the forward slip and the backward slip, only that. Okay, and today we are going to take another session. It's the continuation of single phase induction motor. It's nothing but power stages in single phase induction motor. Okay my dear, draw this figure. Input power, there will be air gap power, okay, listen my dears, draw this figure. Draw this figure. Draw this figure. This is not that much important my dears, but no, anyhow, if for our unluck, no, if for our unluck, if it is asked from somewhere from this diagram, we won't miss, no? So that's why. Okay, listen. So I hope it is you drawn. Listen my dear. So power stage in single phase induction motor is very much similar to that of the power stages in three phase induction motor. What we studied in three-phase induction motor, there should be an input power. Of course, we know that there will be an input power. From that is the input power we are giving to the stator supply, right? Stator supply. So there are stator core losses as well as stator copper losses. So subtract that from that input power stator losses. It is stator losses contain stator core loss plus stator copper loss. Okay. And the remaining power will be available for the air gap, right? The remaining power will be available for the air gap, and the air gap power in single phase induction motor comprises of two things, that is the air gap power by the forward flux, air gap power by the backward flux. Am I correct? Because it is the single phase induction motor is always what deals with the double revolving field theory. So whenever you are going to derive something related to single phase induction motor, there should be always some forward thing as well as the backward thing. That is, you have to remember all the time. So the air gap power will be nothing but the air gap power by forward plus PGF and the air gap power by backward flux, that is PGV. And from that air gap power, it is, so this is stator and this is rotor, my dear. So in between the air gap, so in air gap this much power is coming. So from that it will subtract the rotor copper losses, right? That means the power available to the rotor is called the air gap power. Okay, the power available to the rotor is called the air gap power, and from by using that power the rotor starts rotating. So during that rotation the rotor incurs some losses, right? That losses is called rotor copper losses. Rotor copper losses, and the remaining energy, after the current which is flowing inside the rotor, and the remaining energy or the power will be utilized for developed power or mechanical power developed. Is it clear? You already explained in three phase induction motor. We gave stator supply, there will be stator loss, and there is an air gap, so air gap power will be something there. It is available directly to the rotor, so using that the energy conversion takes place, and there is a flow of current inside the rotor happens due to mutual induction. So that rotor current flowing through the rotor copper wires, so what happened, there will be a losses, rotor copper losses, and after the rotor current reaches to the utmost point of the rotor, there will be some power developed. That power is the reason for the rotation. The whole power upon the rotor is not the reason for the rotation. The reason for the rotation is that after the losses incurred by during its journey from the rotor periphery to the innermost point of the rotor, that is the shaft point of the rotor. Shaft point is in the inner point. No, rotor is a bundle of winding. This is, suppose this is rotor, means so all contain bundle of winding. So during the tragedy or trajectory, not a tragedy, trajectory, it's motion. During that movement of current through the rotor winding, there will be rotor copper losses. So this is rotor copper losses. So subtract the rotor copper losses, the remaining power will be the power developed. Again, the power developed will be comprised of two things: power developed by forward plus power developed by backward. That is PMDF and PMDB. Okay, and again that power developed during the rotor acquires energy for the rotation, but during that rotation it has to overcome the friction or the mechanical or windage losses. So what happened? Their subtraction of mechanical losses will happen. So the remaining will be the shaft power or the running, the effective running. Only thing you have to remember here is that you have an idea of this thing. Definitely you have an idea of what is happening in each steps. Definitely you have an idea. And other thing, see my dear, the rotor copper loss due to forward flux is nothing but S into PG. We already discussed it in three phase induction motor that the rotor copper loss in terms of slip and the air gap power is PRC is equal to simply S into PG. Am I correct? PRC is equal to simply S into PG. Similarly, the PRC due to forward flux is called PRCF, which is equal to S into PGF, where PGF is the forward air gap power, and PRCB means the rotor copper loss due to the backward flux. So what will be the slip when we are considering the backward flux? The slip will be not S, it will be 2 minus S. That is the main thing you have to remind. So 2 minus S into PG into EB. So PACR divided by PG PRC into B will be equal to S into PGF divided by 2 minus S into PG into B. This equation is you have to remember. That's all. So this is the power stages in a single phase induction motor. Is it clear, my dears? Is it clear? Next you have to see shaded pole motor. So in the last class itself I gave an idea of Why the single phase induction motor is not self-starting? There is no rotating magnetic field. And how can we make a single phase induction motor to be a rotational motion? I mean, to be a normal motor like a rotation. How can we do that? We have to introduce two types of winding. One is already there, that is called the main winding. We have to introduce another winding called the auxiliary winding along with the capacitor, so that there will be some lead and lag mechanism between the auxiliary winding current and the main winding current, so that there will be a rotational magnetic field. Then only the rotor will rotate, and whenever the rotor attains a speed of 70 to 80% of the rated speed, we can switch off the auxiliary winding by using a centrifugal switch, so that the motor can continue its rotation by using the main winding only. Even though the torque is pulsating, when it reaches a speed of 70 to 80%, that pulsating torque is enough for the rotation. Okay. So that was the way in which we have to start the motor, and in fan and all we are using that type of motor. Okay, now we are going to move another type of single phase induction motor. We know that a bare single phase induction motor is not self-starting, my dears. So we have to introduce some arrangement, or we have to make some arrangement in the single phase induction motor, so that it can be self-starting. So depending on the methods we are providing for make the single phase induction motor as a self-starting one, the motors are classified. Single phase induction motors are classified according to the way in which we are starting the motor, or which mechanism we are using to start the motor. That's all. So first one, it is called the shaded pole motor. Okay, it's very important actually. Shaded pole motor. Draw this figure, my dear. Listen, my dear. So this is the structure of a shaded pole motor. This is the structure of a shaded pole motor. See, the stator consists of a salient pole type stator. The stator is actually a salient pole type stator. Salient pole means there are projecting poles. The poles are projected from the surface of the stator is called the salient pole. See, the poles are projecting from the surface of the stator. That's why it's called the salient pole. And there will be a squirrel cage rotor inside the stator, and there is a special arrangement. That means we are making a slot on the surface of the pole or pole face, and we are connecting a shading coil or shading band in this, like this arrangement. We make a slot and we are inserting some band there, and the band is called the shading band. It's not very copper, it is made up of copper. It is made up of copper. Okay. And in opposite direction or in opposite manner, in the other poles also, suppose it is a simple pole, 2-pole machine. Okay, just consider 2-pole machine for the simplicity for understanding. Okay, and in next pole, what we are doing, opposite direction we are making the slot, and we insert a copper shading band again, like same as that of this copper shade band, and we are giving single phase supply to the stator. Single phase supply to the stator. What happened? Due to that, there will be, by using an external magnetic field, DC magnetic field, this is permanently making a north pole and south pole. Okay, no change in that. There we are making a north pole and south pole by using separate DC winding. We are making that, and due to this single phase supply, our aim is you can make this north and south pole by split rings. Suppose we are giving single phase supply here, and you have to convert into DC, and you can directly connect here. Okay, in that manner also you can make the polarity and then just fix it. No issues there. And what we are going to do is, see my dears, here due to the single phase supply, it is, we already told you that it is alternating in nature, that we know, right? It is alternating in nature. So the alternating current is flowing through the stator surface. So what happened? This alternating, currents, the alternating currents or the alternating voltage induce some voltage in the copper band, because copper is a conducting material. So whenever a conducting material is placed in alternating magnetic field, I'm again saying it is a single phase alternating magnetic field only, but not a rotating magnetic field. If it is a rotating, means there is no need of such things. It is directly the rotor will rotate. It is not rotating, it's a pulsating, but it's a time varying magnetic field. Okay, so whenever the time varying magnetic field is flowing around the stator, this copper conductor is situating in a time varying magnetic field. So according to the Faraday's laws of electromagnetic induction, what happens, my dears? What happens? There is an induced EMF in this copper band, and this induced EMF is always trying to oppose the cause to produce it. Here the opposing factor or the opposing cause is nothing but the magnetic field. Correct? The magnetic field. So what happened? What happened, my dears? These copper bands will oppose us a certain, that means there will be a current which is flowing in the copper bands, and that current will opposes the magnetic field, the resultant magnetic field or the magnetic field around it in opposite manner. So there will be a net decreasing magnetic field surrounding this region. A net decreasing magnetic field surrounding this region. That means it is continuously opposing. So there will be an opposing factor all the time around the conductor. Am I correct? So there will be a decreasing magnetic field around its portion. That means compared to this region, this is a very big N. It contains certain flux density and it is a very big N. And this small region, my dears, there will be a shortage of flux happens, or there will be a dip in magnetic flux happens due to this opposing effect of the conductor. So there will be an increasing flux here and it is slowly decreasing here. This is the case now. So there is a flow of flux from here to here. That means the here is phi will be high, here phi will be low. So from high to low there will be a flow of, or there will be a relative flow of flux from this high flux density region to low flux density region happens. That means this is the case of this pole, and the same case will happen here also, and this will be in opposite direction. Correct? There is its highest, and here due to this opposing effect and all, the region around this region will be slightly demagnetized, not fully, slightly demagnetized. For positive half cycle, it will oppose in certain manner. For negative half cycle, it is opposed in another manner. In short, there will be a dip in the magnetic field. So there is also a small potential variation of fluxes of in this direction. Here is high and here is low. So what happened here? Here there is a rotational effect of flux happens. Here is a rotational effect and here is a rotational effect of flux happen, and that too in very speed, that too in very speed manner it will happen. So what happened? The rotor gets the enough rotational effect around him, and the rotor started rotating as that of the three-phase induction motor. Is it clear? The working and all, just for your understanding, okay. The examination point of view, it is actually not at least important session. No, shaded pole motor and all, this least important session for the examination point of view, but for the analyzing, for what understanding purpose, it is enough. Okay. So there will be a difference in flux happens around each pole. So there will be a rotational effect of flux will occur around the rotor, and the rotor start rotating. That's all. Okay. And the thing you have to note is that now I am going to discuss that things. So the constructional or the working side, no one will ask you. No one will ask you the constructional and working side and all. But the points I am going to discuss now onwards will ask for the exam. Just note that point. Just note that point and read and study. Okay. This all comes under the what? Special electrical machines concept. So this will not be, the theory session will not be asked, definitely will not be asked, but certain points I am going to discuss, it will ask. Okay, just note down that point. So the rotor is a cage rotor, right? Am I right? Cage rotor. Stator contains salient pole. These points only just you have to note, my dears. No, not nothing. Not more. It is the cheapest special electrical machine. Cheapest special electric motor. This point now very important, my dear. This point is very important. And another point, it is the lowest power factor motor. This is also very important point. And it is impossible for reversal of its speed. It is impossible for the reversal of rotation, because it is permanently cut in the pole face, right? We permanently cut in the pole face and we inserted the copper ring there, so we can't change the direction. It is always clockwise plus, that's all. And where we are using this table fan, computer fan, exhaust fan, hair dryers, refrigeration, fan, tape recorder, projectors. The things you have to note in this session is only this, bus. No constructional diagram, no working, no, you know, don't need to remember all this. You just need these important things, in which this is very important. Cheapest specialistic. What is the cheapest specialistic electric machine? It is a shaded pole machine. Lowest power factor machine of among what other special electrical machine is that a shaded pole machine. And which machine is impossible for speed reversal? It is one of the machine for which is impossible for what? Rotational reversal. So this is also very important point, and this is the application. So applications are really important, so you have to know these applications also. So that just you want to know from the shaded pole machine, okay? That just you want to know from the shaded pole machine, okay? Next special electrical machine is called universal motor. So just note down the points only, nothing more will be asked. Universal motor. First point, works in both AC and DC. First thing, and second, it is a self-starting motor, no issues there. Self-starting motor, and low efficiency and sparking and low efficiency and sparking at the brushes. It acts as a series motor. Speed is very high, greater than 20,000 RPM. Greater than 20,000 RPM. And applications, hair dryers again, trimmer, mixer in our home now, it is a universal motor. Juicer, vacuum cleaner, etc. So these are the main applications of universal motor. Best example is our home vacuum cleaner, no? Vacuum cleaner. I think vacuum cleaner may not be available for all homes because it's slightly costly. So mixers are everywhere, no? Mixer and juicers are everywhere. So mixer or normal mixie, na? Mixie, and juicer means juicer mixie, that's all. So these are the common examples for universal motor. So that can be operated in both AC and DC, both AC and DC. Suppose you are moving or you are going in a train. Suppose there are sufficient plug point there in order to charge the battery, I mean in order to charge our mobile phone. One day I traveled in a train, and one person which were sitting opposite to me, there are two persons actually, were sitting opposite to me, a husband and wife and a small child, and it is clearly indicated, or it is clearly wrote in the plug point of the charger. We are plugging charger now. So that region content, it is only for charging mobile phone. So that lady, what she did, she had a small mixer in her hand for making food for her baby. So what she did, she looked everywhere and she confirmed no TT and there, okay, and she take that mixer and directly plugged it into the plug point of the train. Suddenly that region I mean the mixer started running, it started running, but it contained a large current inflow, right? Because the mixer is and it will absorb very large current. So what happened, not the whole train but that compartment power off, I mean blackout happened, only that compartment. And suddenly the electrician came and noticed this lady, and not that lady actually, someone plugged something into the switch, and that is the reason why the whole blackout happened, and he rectified that, okay. So I noticed one thing, that mixer work in DC also there. That is the only thing I want to tell you. Okay, for that I took this example. Okay, my dears. So hair dryer, trimmers, mixer, juicer, vacuum cleaner, etc. are the universal motor. Okay. Next special electrical machine is a reluctance motor. Reluctance motor. It is a single phase self-starting synchronous motor. Reluctance motor is a synchronous motor, my dears, not the induction motor type. It's a synchronous motor. It runs at synchronous speed, so it runs at synchronous speed. And third point, used in electric clock timer or recording instrument. That's all. Okay, that is all reluctance motor. You just note down this point and just read. That's all. And next, hysteresis motor. Hysteresis motor. It also self-starting. Very low noise, very important point. Or lowest noise, you can write like this, lowest noise. Lowest noise, used in tape recorders, and smooth and constant speed. Smooth and constant speed. Very important point is no winding on stator. This is very important point, my dear. No winding on stator. The special electric machine having no winding on stator is the hysteresis motor. And lowest noise motor also the hysteresis motor. It is also a single phase synchronous motor. Single phase synchronous motor. Next special electrical machine is called a stepper motor. Stepper motor. See, what is the stepper motor means? In our clock, in a normal clock, that is a stepper motor. So I think you might have done a project in solar tracking and all, right? Someone did, and you already, I think you saw that, right? So the tracking of the sunlight happened by using the special electrical machine that is called the stepper motor. That means the rotation is not uniform, not like this, but stepwise. The movement is stepwise. That is called the stepper motor. And the thing you have to note here is called step angle. Step angle is equal to ns minus nr divided by ns into nr into 360, where ns equal to number of stator slots, teeth, and nr will be number of rotor teeth. Number of stator teeth per pole and per pole. Okay. And the applications solar tracking or solar power tracking, computers, control system, or computer control system ideas, computer controlled system, computer controlled system, and floppy disk, and drivers, printer, spacecraft. So the peculiarity of this type of motor is, my dear, stepper motor means it is the movement is not uniform, but not exactly the rotational, but stepwise rotational motion. Our watch itself is a stepper motor, and other were solar power tracking, we are using stepper motor, computer control, floppy disk and all, we are using that. Drivers, hard drive. You just Google it, the construction, I mean internal structure of a hard drive. There is an arrow like this, and the arrow is continuously moving like this. The disk is rotating, but when reading, it will read in this layer, means the pointer will be here. The next layer, the pointer will be there. Next layer, the pointer will be there. Next layer, the pointer will be there. CD, our DVD player, CD player and all, this mechanism is using. There also we are using a stepper motor. And printer and all, we are using spacecraft, we are using the stepper motor. So very wide application is there and very important motor. Okay. In examination, a direct question will be asked from this step angle. What is the step angle if the stator tooths are this much and the rotor tooths are this much? If you know this formula, you can directly find. Nothing more than this will be asked from this stepper motor. That's why just you need to just point, take these points and just read it first. Okay. And next, repulsion motor, my dear, repulsion motors. And the points you have to note here, it's the highest starting torque. Highest starting torque among special electrical machines. Okay, that's all. That means its starting torque will be proportional to IS. It is like a DC series motor, na? Similar to DC series motor. That's all. And already explained that capacitor start motor. No need to explain that, huh? No need to explain that. We already explained capacitor start, capacitor run motor. Another thing is capacitor start and run motor. This is another type of motor in which in normal capacitor start motor, after the motor pickups to 70 to 80% of the normal speed, we did what? We switched off the capacitor from the supply by using a centrifugal switch, and the motor will continuously run. But in some motors, some motors are there, for example our fan, ceiling fan, there is capacitor start and run motor. That means the capacitor is always connected there. The capacitor is always connected there. Capacitor start and run motor. Okay. See. And AC fan also. AC fan. Okay. application, just you note these applications. Sorry my dears, I wrongly said, in our fan we are using a permanent capacitor motor, not the capacitor start and run motor. Okay, in fan we are using permanent capacitor motor. Okay, permanent capacitor motor. Capacitor start and run motor applications are centrifugal pumps, refrigerator, lathe, AC fan, small drill machine suits. Machines. And you have to note one more thing. There are two capacitors, C1 and C2. C1 is providing starting torque, and which is paper or oil capacitor, and C2 provides excellent running condition also improves power factor, and this is made up of electrolytic capacitor. So one is for starting purpose and other is for the running performance. So for example in AC and all my dears, AC, in refrigerator, fan and all, it is throughout 24 hours running now. In our country and all, the AC may not run 24 hours, but in Gulf countries during summer season the AC runs for 24 hours. They will not stop AC. So there should be, the performance should be good for the continuous operation, that means continuous running operation. What happened, there should be a power factor improved version. So for that we are using a capacitor C2, which is electrolytic in nature, which is for improvement of the power factor. Okay, so that's all for that capacitor start and run motor. And the remain fan we are using permanent capacitor motor. It is also a type of what single phase induction motor, my dear. There is, instead of that centrifugal switch, we are inserted some capacitor now. There will not be any centrifugal switch in permanent capacitor motor. We have an auxiliary winding directly connected capacitor in series. We have a main winding bus. The capacitor is always connected to the supply, like our fan. The fan capacitor is always like connected to the supply now. So similar way, the capacitor is always connected to supply. Then that type of what single phase induction motor is called the permanent capacitor motor. That's all. That's all. Is it clear? Next, servo motor. Servo motors designed for AC. It may be 3-phase or 2-phase and DC. It is a controlled motor. Used in I don't know, in our syllabus, I think in S7 or S6, 6th or 7th semester, there was an experiment regarding the servo motor. Servo motor means it is a control system. It is a control system motor. No? You can control it from remotely you can control it. So you just remember these points. It will work on AC and DC. There will be you can transmit something and you can receive the control signal and you can operate that motor. Simply transmit from a motor and you will receive from other side, and suppose you turned here, it will turn to there also by using the control signal manner. Okay, that control signal is the working of that type of motor, and usually it is used in the control system. Okay, so that these things you have to note down. Okay, an applications used in radar, robot, etc. Tracking and guiding system used in tracking and guiding system, and used in computers. Next, that's all. So that's all for the special electrical machines and its application. So we will take a new session, that is a synchronous machine or alternators, very important, from tomorrow onwards. So that's all for today. So bye.